was to, she was a software engineer, but her job was to build, you know what UAVs are, the unmanned aerial vehicles? General Atomics builds those Predator drones, right? That's what they did. And so that's the team she worked on. And her job was to test that flight simulation software. Because once we put that software on that device and launch that stuff, it kind of has to perform, right? It kind of has to perform. Those are $1 million devices at that point. You don't want bad stuff to go on your $1 million device, right? Like I get upset sometimes, like I bought one of those like $100 drones, right? And I got mad when that crashed. Imagine how you would feel if $1 million drone crashed. All right? So some of the trade-offs, binary search, right? At most, it performs long two-in comparisons. So these are some of the benefits to binary search. The disadvantage is it has to be sorted. But that's, in my opinion, that's really not a disadvantage. That's kind of advantageous. Because once it's sorted, I can use binary search. So now we're going to look at some sorting algorithms. Okay? So when we talk about sorting data, the data could be alphabetical data, it could be alphanumeric data, it could be just numerical data, right? So we know that we can go in an ascending order or go in a descending order, right? Least to greatest, greatest to least, right? From A to Z, from Z to A, okay? And so the two algorithms that we're going to look at are the bubble sort and the selection sort, okay? Bubble sort and the selection sort. Okay, so let's talk about the bubble sort and why it's called bubble, right? So I have this container. I have this container with some values. The whole purpose of my algorithm is to sort my container, okay? And I want to go from least to greatest, okay? I want to go from least to greatest. So, the first thing that we're going to do is compare the first two elements. Here is element 0. Here is element 1. I'm going to test them. I'm just going to call it array. Is the 0th element less than the element in the 1 position? So they are in order. So I do not need to swap them. Okay? So if they were out of order, I could put them in order. I can literally have them swapped. But that's not the case here. They are in order. This is true. This guy is less than that guy. Cool. They're in order. Let's move on. Now let's compare the next values. So we kind of moved, we moved down, now we're back here. Is this element less than that element? No. We need to put them in order. We're going to swap them. So let's put them in order. Two and 11. And let's move on. Angel.
Sure. Would you, is there some sort of method or function to do that, or would you use a temporary variable?
Good question. We would typically write a swap function. And in the swap function, we would accept two arguments by reference, Why do we want to accept those arguments by reference?
It gives you access to modify the data and
Right, because it's going to give us access to those physical memory locations where we're going to be able to swap those values in the container itself. Okay? So yes, we would typically use a swap function that takes two arguments by reference, so we have access to that memory space, and we'd swap them there. Good question. Okay, cool. We made the swap, now we moved on. We're going to do another comparison. Are those values in order? They are not, right? So what are we going to do? Swap them. We iterated back. Are they in order? And then what we're going to do? Are those values in order? Cool. Now we start over. Now we start over. Now we come back over here. And we continue through this process until there are no more swaps. Until everything is in order at that point. Right? So here, are they in order? No? Question?
that was a 9 and a 2, right?
A 9 and a 2. So notice, this is why they call it the bubble sort. We have to bubble those larger values up. It's kind of a laborious process. Not that very efficient. Question?
Did I see you update the first one at the very end?
No? The first one at the very end? Oh, no, wait, what do you mean?
Yeah, like I saw you change that 2 and the 9.
Well, yeah, because they're out of order.
He's going doing it again.
Yeah, we went through it again. We went through the end, and then we came back around. So what does that kind of mean with respect to how you think we're going to program this stuff? And they're probably going to be, 4 loops? Or we're going to have one or multiple? Yeah, we're going to probably have some nested loops. Because one loop to traverse us through, and then the other loop to bring us back and start again. Right? Yeah. Good one. Good one. But yeah, I reached the end. And when I reached the end, my list still wasn't sorted. I still have data that's out of place. So I have to come back. I have to come back and start all over. Look, this 9 is still out of place. Right? And so I still have to come through. Are they in order? No. So I got to keep doing it.
So once it's finally in order, after you updated your last one and put it in order, it will still run through it one more time.
And validate that it's all in order. Right? And so we go here. Like I said, you can kind of see that this process can take a minute. Right? A little lengthy. Right? So this is the bubble sort. Called that because we bubble the values up. And we go through it and then come back. And go through it and come back. Performing swaps as needed. And we'll do that continuously until we don't need to do it anymore. Okay, so everybody good with this? I'm going to take this down. So again, right, we had our container, we had some values in it, we wanted to go ahead and assess them to see if we needed to do any swaps, and we just kind of go through that process, right? They're not in order, so we need to put them in order, right? They're not in order, so we need to put them in order. They're not in order, we need to put them in order, right? So at the end of our first iteration, here's what that list looks like. But again, it's still not completely in order, right? That was only one pass. And so we have to do another pass. And we go through assessing all of our values, determining whether or not they're in order or not. And if they are not in order, then we're going to have to swap them around. And we already said that we can use a swap function to help us do that. And so after the second pass, it actually looks like they're in order. And so we go through and validate that there are no more swaps that we have to do, meaning that there are no exchanges. Okay? So let's pull up some code. Yeah, cool. Get these lights. All right. Look at our function prototypes. Look at our function prototypes. We have one prototype called bubble sort. It takes an array. Notice it's not my constant. Notice it is not my constant. Right? Remember before we were searching and we didn't want to inadvertently modify the contents on a search. Here we are sorting. So we want access to that memory space. We want to be able to modify that contents if we need to. Okay? So our bubble sort prototype, we take an array, and then the search value, or no, the size value. Yeah, the array and the size. And then here's our swap. Notice we're going to take two integer values by reference. So here's my main. I declare an array of size, provide an initialized list, and then I display the unsorted values just to show that, hey, look, they are unsorted. Okay? Look, I'm just using a range-based loop, right? I don't care about the mechanics. I just want to go from the beginning to the end, right? A range-based loop is perfect in this scenario, okay? So cool, use my range-based loop, then I go ahead and I call my bubble sort function, and then again, hopefully everything's sorted correctly, right? I provided the array and the size of my array, and then I just do another range-based loop to show that everything was sorted, okay? So I'm just going to kind of run through this real quick before we look at the code. Cool, that worked out. Nice, check it out. Here's my unsorted values. This is the initialized list that I provided my array. And here it is after it went through the bubble sort. All in order, okay? So let's look at the bubble sort code, right? So again, our function takes an array and the size of the array. And here we have some mechanics that we set up. We have some integer values, one called max element and one called index, okay? So look at, here are our nested for loops. Here are our nested for loops. So the outer loop, we're going to set max element to size -1, so n -1 essentially, right? And notice what we're doing. So let me draw that container up here again. Let's go here. I think it had 6 elements, yeah? Yeah, 6. And I think the initial, I want to put it just how we had it. 6. Oops. 6, 1, 5, 2, 4, 3. Perfect. Okay, so here's our container. Look what we're doing. Look how we're traversing this list. Look at max element, size -1. So we have max element, size was 6, n minus 1 is 5.
Yes.
And as long as max element is greater than 0, decrement max element, okay? Then we have index. Index is 0, and as long as index is less than max element, increment index. So max element starts here and decrements. Index starts here and increments, okay? Notice that. Cool. So the first time through the loop, set up our stuff. Max element is greater than 0. Cool. Now we're here. Index is less than max element. Cool. Now we're here. Index is set to 0, and then index plus 1. So we're assessing these two values. Are they in order? No. Swap them. And look what our swap does. Remember, we're taking two values by reference. And so this kind of, sorry, I didn't mean to throw that at you. And so this kind of goes back to what you were saying, like, hey, how are we doing this? Just set up a temporary variable. Assign A to temp, B to A, temp to B. Down, they're swapped. But we pass these values in by reference. So we have access to that physical memory space. So we're able to modify those values in our physical container. Good? Good?
I just thought that was gonna be like a function library that would do it for you, but I guess you just create the functions.
When in doubt, peek out, right? Cool. So we did our swap. 6 and 1. And remember, the inner loop has to complete fully for every one iteration of the outer loop. So we're still in our inner loop, increment in our index. So now we're here. Well, our index is here. That's an arrow. This is, I'm just going to use I. That's our index, right? And then index plus 1, right? So we're here, increment in our index. Now we're here. Are our values in order? Is that element greater than the other element? Yeah, it is, right? So swap them. Was it 5 and 6? Yes. Okay. Swap them, increment index. Is that value greater than the other value? Yeah. Swap them. We did our swap, increment index. Is this expression true? Yes, it's true. Right? It's true. This value is greater than that value, right? Right? Swap them. Increment index. Is that true? Bam. We completed a full iteration. Now we're back up here. Max element got decremented. Right? Max element was decremented.
That's because the greatest one's already at the end, right?
No. No. The greatest one truly could have been in here still. It could have been. It could have been. This is just helping to whittle down our search surface. And it's a valid way to solve this problem. it's a valid way to solve this problem. So, max element is 4, right? Now we're back in here. We're back off at 0. Is index less than 4? Cool. So we're back here. Right? We're back here. And we just kind of continue through that whole process again, right? Evaluating, swapping. So we're going to swap. 2 gets here. 5 goes here. We continue down this path. I think this was a 5. I don't know what I was really. 2, 5. We'll swap them. So 4, 5. Swap them. 3, 5. Those are good. We'll come back and iterate again. We'll come back, and I think one more time, and I think at that point we're done. All right? So let's put some cheater code in here to kind of help us see this thing running, right? Some of the stuff I like to do, so that way we can actually, it doesn't look like magic. So I want to keep track of actually how many times I've gone through this. Okay, so I'm going to do.
With decreasing the max element and the outer scope, does that mean one of the elements in the array is in the position it needs to be in?
Say that again?
Since we're decreasing this after every iteration of the max element loop, since we decrease max element by 1, that decreases the surface that was mentioned in the array. So wouldn't that mean one of those elements is in the position to be in?
Watch. Just look at it. That's why I like doing this, because it demystifies our program. Right? We have 6 elements, right? We went through that 5 times. Because after 5 iterations, it should be in order. I think after n-1 iterations, it should be in order at that point. I think that's what it's taking advantage of. I think that's what it's taking advantage of. So we had our unsorted list, and look at my maxed element, just decrements all the way down. I went through that iterative process. My outer loop went through 5 times, and then bam, now I'm at my sorted list. Okay? It helps demystify that, right? It kind of puts some context, like how does this thing really work? That's why I like doing stuff like this. Because it opens it up for you. Like, oh, okay, I see. I get that. I get that, right? Questions about this guy? Bubble sort. Bubble sort. We bubble things up, okay?
So it would always go through the array n-1 times? Or-
The maximum,
Yeah,
yeah, it will all, like, for this, in this instance,
okay.
how this code is structured, the algorithm that it implemented. I've also seen this algorithm implemented that keeps track of a Boolean variable called swap, and that's a way to kind of short circuit this.
Yeah,
If you've gone through one pass and there are no more swaps, because maybe you had a kind of pre-sorted list that wasn't completely unsorted, like a lot of the values were already there, then it becomes kind of inefficient to do this.
Mhm.
So I've seen another algorithm that has a Boolean variable called swap, and if there are no more swaps, then we short circuit it to come out. Okay. That was bubble sort. The benefits, easy to understand and implement. Not bad. Walk through that array, compare values, swap as necessary. Keep going until we don't have to swap anymore. Okay? Disadvantage, think about this at scale. Yeah, 5 elements not bad, 10 elements not bad, 1,000 elements, 100,000 elements, 1,000,000 data points, right? Think about time series data. Think about the telemetry we get on some of our devices that exist out in the field. Think about a Tesla driving down the road and it constantly evaluating stuff, and some test engineer trying to understand that data, right? That stuff shoots off a lot of points in a minute, right? Imagine over an hour, imagine over a day, imagine over the lifetime of that vehicle. Because one neat thing about those devices, and like same thing about like those, what are those things? Those computers with wings? What are those things called? Planes? Planes? Yeah, planes. Those computers with wings? Those airplanes? Right? Think about all that telemetry data that comes from those motors, that comes from the equipment, right? You have a lot of stuff. And trying to calculate averages and statistics based on that, right? It's fine for small data sets. It becomes very inefficient at scale. All right. The next one. Selection sort. Again, let's draw a little container. Two, 9, 8. That's fine. So a selection sort, again, we want to sort something in ascending order, right? Smallest to largest. So the first thing that we're going to do is locate the smallest element in our array, then exchange it with the element at the 0th position. Right? Because if we find the smallest element in our container, then we know it ought to be in the 0th position. Okay? Then we locate the next smallest element, exchange it with the element in position 1, and then we continue until all elements are arranged. Right? So let's give this a whirl. So we're going to have to keep track of some stuff, like mainly the smallest element that we have so far, and like the index of where we're putting things, right? So, let me see. Just want to make sure that I'm walking through this. Okay. So I want to keep track of the value and the index. So, and so initially, I kind of just need to keep track of where I start. And what better place to start than the beginning? Okay? So, the minimum index would be 0, and I start off at 0, right? And the minimum value will just say it's 5, okay? Because I'm just starting off here, right? I have to start somewhere. What better place to start than the beginning? Then I iterate through my loop. And I just go from value to value, comparing the next value to what I have known as the min value. Okay? So eventually I get to some other value that causes me to update this. So what do? I swap them, right? I swap them. Bam. So my min value is now 2.